Our first talk here will be Making Sense of Unstructured Threat Data by Zainab and Nicolas. Our presenter is on the data science team at TrueStar, working on improving threat intelligence platforms and workflows. Let's give Zainab a warm welcome.
All right, perfect. Thank you so much for introducing me, but I'm also going to introduce myself. So I'm a data scientist at TrueStar. We do a bunch of interesting machine learning and NLP stuff, and all of that stuff usually has an impact on the product. And one of those NLP things that we do at TrueStar, I'm going to be talking about today. Before this, I got my master's in data science from USF, and when I'm not data sciencing, I'm drinking chai. And I know, I look really nice in this picture, right? All right, so the title of this talk is Making Sense of Unstructured Data. And a lot of people told me that this title sounds kind of boring, and maybe I should introduce some interesting pop culture references. And you guys, I tried, I really tried to think of something, but I could not. And therefore, I'm going to leave you with this. Apologies in advance to people who do not watch Game of Thrones, but I swear to God, this makes sense. So, Daenerys speaks a bunch of different languages, and this is natural language processing, right? So, yeah. All right, so we're going to dive right in and talk about the purpose of this entire exercise. And the purpose of this exercise was to establish some sort of a link between two completely diverse sources of data. So you have data from the NIST vulnerability database, and you have data from the MITRE ATT&CK framework. And even if you do not have a security background, I'm definitely going to go into the details of what each of these things means. So don't worry about that. Let's start with the MITRE ATT&CK framework. So I feel like in order to sum it up, the two most important concepts that anybody needs to know about the MITRE ATT&CK framework would be tactics and techniques. So a tactic is an overarching objective, right? It represents the why, or what are you trying to achieve. And a technique essentially represents how you're going to achieve that tactic. So to make it more concrete, let's look at an example. On the right-hand side, the left-hand side, you have a really pretty graphic of a matrix. I made that myself. And every single column of the matrix represents a tactic. Every single row of the matrix represents a technique. So initial access, let's say, is a tactic. And drive-by compromise, exploit public-facing applications. These are all techniques that you can use to accomplish that tactic. So the entire point of showing this slide was to just make sure that everyone knows how data-rich this repository is. Once you're able to connect any indicator data to the MITRE ATT&CK framework, you have access to any threat actor groups that might be targeting you, any mitigation strategies for the techniques, detection methods, as well as any references that may have been made in the past in terms of, a malware or a software that leveraged that technique, or any other article that was written about that technique. So, to make it even clearer, let's look at some of the attack objects and look at how they're related to each other. So, there is the concept of an adversary group. These are the bad guys, and they would use a technique which accomplishes a tactic, right? And the adversary group, in order to use that technique, will have to use a software. So the software in this case is the bad kind, right? It's a malware. And the malware will implement the technique in order to accomplish the tactic. So what am I introducing into this entire framework? I'm introducing the concept of a vulnerability. So this is where I believe a vulnerability fits into this entire graphic. Right? A malware would target a vulnerability which would implement a technique which accomplishes a tactic. So if you're foggy on the idea of a vulnerability, it's essentially something that's wrong with your software, and there's threat actors, right? There's bad guys out there that want to target that vulnerability in order to target you. And essentially what you want to do is you want to patch those vulnerabilities up so you're safe from all of those targets. So let's go into the fun NLP stuff. And I'm sure every time you guys open LinkedIn, you see the words NLP, AI, data science, and I'm sure most people are just tired of hearing these words. And I'm sorry about that, but I promise this isn't fake. We actually did this stuff and it works. So let's dive in. Word2Vec is a cool NLP technique. And what does it do? It teaches a computer to understand, interpret, and manipulate human language, right? And why do you want to do that? You have a bunch of unstructured data, and it has to make sense mathematically somehow. So what you're going to do is you're going to take all of that data and convert it into numbers. Now, the how part is actually what's really interesting. So how does Word2Vec actually make sense of all of those words, right? It works kind of like our brain does, except like all of that stuff is happening unconsciously. But imagine if you don't know another language and you hear a word from another language thrown around with a language that you do know, right? You're going to use the context that you do know of to understand the meaning of that word. Similarly, like that's just how Word2Vec works. So as the example I have over here is I see ants on the tree. And let's say that your target word is ants. So you're trying to understand what the word ants means. And I mean, you're going to leverage the words that you see around ants. So I see, on, and the, in order to understand what ants means. Now you're probably thinking, but wait, like none of these words actually convey the meaning of the word ants. And that is true, right? Like you can pretty much see anything on a tree. You can see trees, branches, pretty much anything. Did I just say you can see a tree on a tree? I think I did. Anyway, so my point is that there is going to be other sentences in your corpus that will actually have words that are representative of the word ants. And what happens is it goes through this neural network, and eventually what you end up with is a vector that represents the meaning of the word ants. And on its own, that vector means absolutely nothing. But if you look at that vector in conjunction with other word vectors, it means everything. So the vector for the word ants should technically be close to the word vector for spiders, right? Because spider is also an insect, ant is an insect, beetles maybe. And similarly, let's say you have the vector for the word king, and if you add another vector to the word king, you should get the vector for the word queen. And that same relationship should persist between all the other male and female objects. So far we've done like a sort of like a toy example. Now let's dive into what we actually did. So I know this is an information overload, but we just talked about Word2Vec and how it leverages context in order to understand the meaning of words. Now we're going to talk about Doc2Vec, and the idea is still the same, still leveraging context, and what you're trying to do is you're trying to predict a vector for a document, except this time it's a paragraph, and you're taking context words from the paragraph in order to get a vector for the paragraph. And what eventually happens is it goes through the neural network, and you have a neat little vector that represents the meaning of that document. So let's go over our process real quick. We had data from the NIST database, we had data from the attack framework, all of that data comes in, we clean it up, we get rid of anything that we feel is not really going to convey the meaning of that document. So we got rid of any emails, any URLs, all of the stuff that we thought was unnecessary. After that, you tokenize it. So tokenize is essentially just a process of breaking a paragraph down into its component words. After tokenizing it, it goes through the algorithm, which is the brain or the neural network that I just spoke about. And what you end up with is a vector that represents the meaning of every single document in your corpus. So now you're probably wondering, okay, we went through all of this, what came out of it? So I'm going to preface this discussion by talking about some interesting CVE clustering that I did. So I clustered together all of the CVEs that I had, all of their word vectors, all of their paragraph vectors actually, and I found some really interesting clusters. So there was one which only had vulnerabilities from web browsers. And I thought it was really cool how the algorithm actually managed to recognize that Google Chrome, Safari, Mozilla Firefox, and Opera are all web browsers and put all of their vulnerabilities together in the same cluster. Another cluster that I felt was worth mentioning was this one. So this one just had something about DLL hijacking. Honestly, I've read through so many vulnerabilities by now. I manually labeled all of this data. I still don't really know what's going on here, but I just know a few words like DLL, and that's what I saw over here. It was all talking about path reversal vulnerabilities, DLL hijacking. That's what was going on in this cluster. And there is a reason why I brought this up. So our initial goal with this entire exercise was to make a connection between the attack framework and the vulnerabilities database. So over here, I have an example of an attack technique. It's a description, and I don't really expect anyone to read through this. Just really focus on what I've highlighted, which is dilib, right? And what happened is it managed to make the connection between dilib and a vulnerability description, which talks about DLL. Now, what I also want everyone to notice is dilib is not mentioned in the vulnerability, and DLL is not mentioned in the attack description. However, it leveraged that context that I've been talking about again and again so far, and it managed to understand that DLL and dilib actually mean the same thing, and that these two are probably connected. And now, why did I show you that cluster from DLL hijacking? Because if you've managed to connect this technique to even one vulnerability, you know all of the other vulnerabilities that look similar to this vulnerability. So essentially, you have managed to connect this to all of the vulnerabilities about DLL hijacking. So let's actually see this in action. Does it really work? I have uploaded all of this data in a repository. Do not worry about that. Let's do a quick run through of this notebook. Just gonna talk like really vaguely about everything, but everything's on GitHub. So got the libraries. There's a few helper functions that clean the data, get rid of any URLs, any citations. There's a wrapper function. Then there is functions that I got from the MITRE GitHub repository. Super helpful, by the way. Definitely check it out. All of these functions essentially help me fetch the data. And then you extract the data from MITRE as well as NIST, dedupe and clean all of that data up, create tuples, get it in a format that the algorithm accepts, set up doc2vec training. I tried 3 different models just to make sure that I had the best results. And the one that worked best for me was distributed bag of words representation. If anybody is interested, I have linked the 2 research papers that I read for this, word2vec as well as doc2vec, in my slides. Go through them, super cool. So over here is an example of a vulnerability and like what other vulnerability came super close to it. And again, sorry, it's annoying to read, but they're actually very similar. I read through them, so I can promise you that. They're also on GitHub, so go through that. Then let's talk about clusters. So I talked about how I made vulnerability clusters, and this is an example of that same cluster. So you have a cluster that's about DLL hijacking, and we managed to connect that to an attack pattern. So this is the example of the attack pattern that I showed. Talks about dilib, and it's connected to a DLL hijacking vulnerability. I'm sorry that I went this fast through this, but definitely look at GitHub. Everything's there. You can take your own time and like really slowly go through this. So I've shown you sort of a demo. Let's actually start talking about results. How well did this work? Now, the thing with this kind of stuff is when you actually want to evaluate such stuff, I had to like manually peruse all of these clusters, read through all of these vulnerabilities, see if the clusters made any sense. I actually labeled a lot of clusters myself. Also labeled a bunch of attack and vulnerability links, and these are the results we got. Now, yes, I'm giving myself a medal for 50% accurate associations, and you probably think, wait, no, that kind of sounds not that great. But bear in mind that these are 2 completely different data sets, right? So normally when you do this exercise, it's on a data set that's talking about the same thing or a similar thing. So let's say IMDb movie reviews data set, right? All of those reviews are essentially centered around a movie. Whether or not they're saying good things or bad things, that doesn't matter. What matters is they're all about a movie. In this particular case though, the structures of the 2 data sets are extremely different. So with the attack techniques, you have a very verbose, a very detailed description of a technique, right? Except with the vulnerability data, it's usually a 1 or 2 liner, very to the point, talks about a vulnerability super quick, and that's it. So the point is that connecting these 2 diverse data sets and like managing to get this level of accuracy is pretty decent. And the only baseline metric that I could think of actually comparing this with was the probability of getting it right if I assigned it at random. So let's do a little bit of math here. We started with 100,000 vulnerabilities. We created 100 clusters because that was the most naturally occurring number of clusters. I tried it with a bunch of other numbers. So I tried like more than 100, less than 100. And 100 was the number that we settled on. We felt like naturally that's the number of themes that are represented in this vulnerability data. So the probability of actually getting it right if you assigned a vulnerability to an attack pattern at random is 1%. So this is 50 times better than that. So what does it all mean if you're a security analyst or a security engineer, and how will this entire exercise help you? The only way that I could summarize this was to say organizational prioritization. As an organization, you know in the attack framework where your weaknesses lie. You know what you need to focus on. And if you focus on those techniques, and if you manage to connect those techniques to vulnerabilities, you also know what software you've been using, and then you can patch all of those vulnerabilities and actually, save yourself from threat actors. And that brings me to the end of this presentation. I feel like it was super short, but maybe it's because I started early. Huge shout out to Nico, my manager, who encouraged me to actually do this and told me to own this. Super excited to be representing women at this talk. Also, it's kind of unfortunate that my talk clashes with a diversity in cybersecurity talk. I wish I was able to attend that. But I see a few women, at least like 7 women in this room, so that's great. Thank you for being here. And questions, I guess? Yes. So I'm not entirely sure I understand your question. You're talking about like using a much bigger data set to do this? Mm-hmm. A few, yeah. Mm-hmm. Oh yeah, 100%. So it's an ongoing process. Obviously, as you add more and more vulnerabilities, they become part of the training set, and eventually you will, like, these clusters may persist. Maybe you'll have even newly occurring clusters that come as more data comes in. So 100%, it's an ongoing process, and yes, you can do that. Mm-hmm. All right, so you have the trained data, you have the trained model, right? The only thing that you really need to do is just feed it data. So the functions that I have on my GitHub repository are very friendly. The only thing you need to put in is an attack technique or like a CVE ID, and it throws you everything. Like, it answers all of your questions. So you're welcome.
Any other questions?
Yes. Yes, that's what's next. That's a great question. Very open-ended. Thank you so much for asking that. So I've open sourced this tool already. I'm going to make it better. I'm going to make it more friendly. I'm actually planning on working with a few security professionals. So right now I feel like maybe, like that guy said, maybe I've been focusing on the data science aspect of it, but I need to make it more user-friendly. So the idea is to turn it into a full-blown tool that people can actually use without any discomfort. Yes. Oh, that's actually a really good question. So as I was going through these clusters, I realized that there is a lot of overlap between techniques in the attack framework. And like in some cases, I actually noticed that some techniques exactly the same, different attack IDs. That is very space inefficient. Another thing that I noticed was that some techniques, they actually have this very similar descriptions conveying the same meaning. Obviously, Word2Vec got onto that. But again, different attack IDs, which is something that they need to work on. Maybe they can cluster them together, put them all under the same heading instead of like having several different IDs attached to the same thing. So, yeah.
Any more? We've got some time. Okay. Well, just wanted to give Zainab a token of appreciation from BSides for presenting. Thank you.
Thank you.